Aryan Jain. I'm going to be a rising sophomore at Amador Valley next year in Pleasant, California. And my project is called Attentive. And it addresses goals 7 and 17, which is guaranteeing quality education and integrating AIs safely in a society. So a 30-second description would be, it's a platform that utilizes machine learning, and it is able to analyze students' attention spans, and it reports this information back to the teacher so she can improve her lectures. For this presentation, I'd like the judges to act as local and state educators. So let me begin with the problem. During COVID-19, teachers don't know if their new methods are effective in keeping students engaged and attentive. With tons of distractions all around us, it's easy for a student to get distracted without the teacher realizing. This results in fundamental gaps in students' education, which is going to hurt them throughout their lives. In a study by MIT, 64% of students said that distractions made it difficult to learn. 70% said they had a difficult time learning in this new environment. And 79% said they weren't able to focus during online class as well as in person. Now let me tell you about my solution, Attentive. It's an online tool that helps teachers determine students' level of engagement and focus during class. It creates a report describing the amount of time a student has spent on an assignment, the average attention span while they're working, and times when they're distracted. This can be used to improve online learning and ensure students have what they need to be successful in the future. For goals of Attentive, I'd like to integrate Attentive in school districts and universities worldwide. My plan would be to run a pilot program, gather some data, improve the product, and then get grant funding for large-scale deployment. Now, I'll be turning my video off because my project utilizes it in the demo. Let me go back. Okay, so everybody can hear me, and you guys see the student sign-in section, correct? Okay, so thank you.
Yes.
So now I'd simply click this Google icon, and a pop-up appears where I log in with my student account. In this example, this account right here is the student account. So I'd simply log in. And now, this website is made with Flask, and I also utilize the Google Classroom API to automatically get the students' classes and the students' assignments. However, before we can click Start, we need to go to the one-time calibration feature, which is called Train. This Train, we're training our computer to recognize two categories, whether they're looking front or they're looking side to side. We simply click Train, and a live pop-up appears of, now what we're going to do is we want the student to look at their computer as if they're working for the next 45 seconds. We'd click Start, and a timer appears with 45 seconds. During this 45 seconds, around 500 images are taken, and 500 images are taken of the student looking front, and 500 images are taken of the student looking side to side. And so basically, these images are used to train a custom machine learning model to the student and their environment. This prevents problems like this method of making a custom machine learning model for every student prevents problems such as racial bias, which plagues the AI industry. I used libraries such as OpenCV and TensorFlow to make this machine learning model. And in my test on myself, my machine learning model was able to gain a 99% accuracy. Now, as you can see, the front part has been trained, and now we'd simply click Start and act as if we were distracted. So this is the trained portion, and once this is complete, you've trained your machine learning model. Now, let's go back to the main page. So once you've completed that one-time step similar to Face ID, all you have to do is select your class and then your assignment. And once you click Start, then our program is going to take an image of the student while they're working every second. These images are then analyzed by the custom machine learning model and then compiled into a MongoDB database, which is sent to the teacher in their report. So simply, all you'd click is Start, and then you're done. So now, let me show you the teacher aspect. So it's very simple, teacher sign in. Now, it signed me in automatically because I'm in an incognito tab. But this is the teacher of my Google Classroom. So to generate a report, all I need to do, select the class, select the assignment, and click Generate Report. Obviously, there was only one student in my classroom, which was me. So I put a couple of example tabs just to show that this page would be populated. Now, if we click on me, we can see during my time, I worked, overall, I worked for around 30 minutes. And in that time, I turned 41 times and I had a 22-second attention span. So if we click on my link, a new pop-up appears, and these are the exact times when I looked away from the computer. A teacher could use this information, and let's say she found a pattern where 10 minutes into her 40-minute lecture, she found a lot of students were looking away. A teacher could then go back and change her lecture to be, let's say I wanted to make it more interactive by adding a poll, or let's take a break. And so the teacher can use Attentive's resources, Attentive's report, and then she can create, improve her lessons and improve online learning. So this was my demo, and now I'd like to go back to the slides and reiterate my call to action, which is to integrate Attentive into school districts and universities and provide grant funding to give Attentive resources for large-scale development. Thank you for listening, and I'd happily answer any questions. And I also am going to turn my video back on. Give me just 1 second.
Hey, thanks, Aryan. Couple of technical questions. So yeah, I love the idea of actually like you're trying to use the existing frameworks like Classroom, OpenCV, and TensorFlow. But in reality, people will end up using a lot of other things, like maybe they are using Zoom or some other video solutions.
And so
how exactly will it all get integrated?
Yeah, so Attentive is an outside tool. So it doesn't matter what type of video you're using. Let's say you're using Google Meet or Zoom. Basically what you do is before the lecture, you go to the website and click start. Then it'll just take images of you outside of the outside of any video or lecture you're watching. And so it works universally for all types of lectures, no matter if you're using Zoom or Google Meet or anything else. For the Google Classroom aspect, Google Classroom is a very popular type of online tool. And so throughout high schools in America, basically the large majority of high schools utilize Google Classroom. And so that's the reason why I chose it, as it makes Attentive really easy to integrate with student workflows. And so Attentive works for everything, even if no matter what type of video conferencing you're using.
So I follow up on the security and like privacy of it. I saw that you basically ran all of it on the local host. How much of it is actually done locally in the context of the browser versus like how many things do you have to actually just do a server ping and a round trip?
So that's a great question. And so what we wanted to do is I wanted to make sure Attentive could be run on any type of computer, even the low end. And so the only thing that's happening on the user's computer is just the image is being taken. Then we're going to send that image to our server, which will perform all of the machine learning analysis, and then everything happens on the server. So the only process that's happening on the user's computer is the image being taken. This makes it very CPU and memory efficient.
But then you may need like a massive data center as you scale more and more and more.
And that's why, and this is the other thing that makes Attentive very privacy importance is that once we train the machine learning model, we can delete the images because we can save the model as an actual file. And so every time, once you click end and all the images have been analyzed, we can delete them. And this ensures that all user privacy is maintained, and the space, like getting massive data centers, that it also solves that problem as well, because we'll be deleting the images and saving space.
Okay, thanks.
Thank you for your presentation. The first phrase that comes to mind is correlation does not imply causation. Do you know what I mean by that?
Yeah.
Cause and effect. So my concern about this particular technology is that you're measuring attention based on eye tracking. Is that correct?
So basically, it's looking forward or looking turn. There's two categories, which allows our machine learning model to have high accuracy.
High
So,
accuracy of what? Where
of
you're
two.
looking, but not necessarily what's happening in here.
Yeah, that is true. That is true. Yeah.
Okay, so I'm going to give you an example right now. Out of your judges, you see that I'm wearing a headset, right?
Okay.
And
Yeah.
I'm watching your eyes and you just looked up. I think that you're listening to me. I think you're processing what I'm saying. I'll tell you, there are a lot of people, especially people for whom English is a second language or who have language learning disorders, that cannot maintain a forward looking while also processing the information. And it does not mean that they're not engaged with the material. However, those people are often punished the most severely. And there is a lot of research on this. China is using this type of technology that you're describing, and I have serious human rights concerns about it. As someone who also worked for a neuroscience company that specialized in auditory processing, I would really encourage you to look at the whole learner before we judge a teacher based on attention span of the person's orientation to the computer. I think the goal of what you're trying to do, enhancing learning online, is very commendable, and we have to find a way to deal with this, because I know in particular we have a large population of people who really do have either non-neurotypical learning profiles, or who've had significant trauma, for whom they aren't going to sit still in front of a laptop. Those are very creative individuals sometimes. You can't judge a person's future potential or their potential to learn based on how they sit in front of their laptop. So I really think that you're on the right track. You're looking for a way to measure what's effective, and you're also looking for ways to create feedback between the student and the teacher, and that is so important. As someone who's also been a teacher, you want to see how your students are responding. You can see what's happening from here up. You can't necessarily see what I'm doing with my leg right now, right? So those are all things that you normally have in a classroom environment, where you can have more multisensory learning projects that are far more engaging than necessarily staring at the screen and finishing your essay. It's also really hard with younger learners, and that's part of this challenge that we're having in today's environment with children say kindergarten through 5th grade, who are not really ready to read on their own per se. Like, you're learning to read and then you're reading to learn. Those are different developmental milestones. So again, I think you're really on the right track, and the fact that you're interested in the neuroscience of learning just by wanting to track how people move is really a great place to begin. I would encourage you to keep looking into how students learn, and in particular, look into other types of response rates. So if you could tie eyes with some other kind of emotional cue, that might give you 2 pieces of information. You're more likely to have a better baseline. So thank you for allowing me to share that with you too. I think you're onto something, and you should continue to pursue it.
And so one thing that you addressed was definitely like the student aspect. And just something I want to address really quickly is that Attentive is not supposed to be something like an individual, like a teacher can see, oh, this student did bad, and make him get in trouble for it. What we're trying to do is we're trying to take the majority trend. And so let's say like 60% of the class looked away at this point. And so the teacher can use that information and say, oh, that's where my class wasn't paying attention. I can use that to improve my machine learning model. And so definitely you raised some very good points, but I just want to reiterate that like we're just trying to get the majority class information and use that to help the teacher improve her lessons.
Okay, since you made that clarification, what happens if the reason people are looking away has nothing to do with what the teacher is doing?
So so obviously that is going to happen to some extent. However, that same principle applies for everybody. And so since everybody's doing it, the bar gets we can move. So like with further development, we'll be able to figure out like everybody moves a certain amount of times, but it's not certain that they're all going to move at like 10 seconds into the lecture. just because they weren't paying attention. And so with more data, once we generate more data, it'll become more clear that like what we'll be able to differentiate what is a problem in the teacher's learning and what was just an average attention like turn.
I see. Wait, I also have a question.
Yeah.
Okay, like what's stopping like a student from say like your product is running in the background, right? But then what's to stop like a student from say like switching the tabs, looking at the screen, like appearing to be attentive, but actually be doing something completely different? Like how do you track for that?
So there's a couple things. So one, obviously a student could do that anytime, and that is like a big problem. And so something to address that is Attentive marks the time you click start and clicked end. And so if you're not on the lecture, usually there's a big time disparity between like, let's say I goofed off for 50 minutes, even though the lecture was 30 minutes. The Attentive tracks that. And so with more data being generated, and once I like, with more pursual, we can able to like start creating, we'll start creating like, oh, this seems suspicious. Why did he spend 50 minutes on a 30-minute lecture? And so that solves the problem of making sure that students stay attentive and they're engaged.
Right, but then like for example, if someone just mutes the lecture, like waits until the lecture's over and then clicks end right away, but it's like is watching YouTube the entire time, right? Like there's no way to like really track that, right? Because like their eyes are gonna still be on the screen. They can still start and finish at the same time, right?
And so that's definitely a problem that occurs. However, there is no way except so the only way to stop that is if you are able to create something in tandem with the person with the laptop manufacturer. So I'll give you an example of Chromebook. The only reason Google is able to like lock their Google Forms is because they made the Chromebook. An outside application is not shouldn't be able, at least in my opinion, an outside application shouldn't be able to lock your computer and only make you do one thing. That is too much power for an application to have. And so it is honor system, but I do believe that tracking the start and end time is a good enough solution once we generate more data.
Sure. Okay, I was just asking to clarify. All right. Does anyone else have any other questions?
Yeah, I think like one.
Okay.
Yeah, I think like I'll just leave one comment here. Like users tend to be, I would say, like they'll push the boundaries of what the product or cannot do, particularly when something is doing like an oversight. So I think it's an okay first step and continue to iterate on.
Yeah, so to improve problems that occur, we try to run like a pilot in my local school district. And then obviously once we've worked out and created a deployable model, we can get the grant funding for large scale deployment. So yeah. Any other questions?
I was just going to make a quick comment. This is Samina here. Just in terms of the way you showed the teacher report, it didn't seem very user friendly to figure out what time and where the majority of people. So just, I mean, Joanne made a lot of great points. So I mean, whether or not like looking straight at the camera is even the right metric, but you would want to have something more like some different analytics for the teachers to be able to compare students and like.
Yeah, so that is definitely something I was trying to do, but just because I was only able to test it on myself, that was like one type of analytic that I just had to deal with. So I'll definitely look into that as I pursue it and make it a better product.